In this lesson, we will look at the various types of pumps used in aircraft hydraulic systems. Pumps are used to draw oil from the reservoir and deliver a supply of fluid to the system. Pumps may be hand-operated, engine-driven, EDP, electric motor-driven, pneumatically operated, ATM, driven from a ram air turbine or RAT, or hydraulically operated using a power transfer unit or PTU. The latter three pumps, the pneumatically operated pump, the RAT and the PTU, are usually used to provide a backup supply to an engine-driven pump, thus providing hydraulic system redundancy in the event of engine or EDP failure. The output of the ram air turbine will normally be used as a backup solely to operate the primary flight controls and brakes. A hand pump may be the only source of hydraulic power in a light aircraft hydraulic system, but in larger aircraft, hand pumps may be employed to allow ground servicing to take place without the need for engine running, enabling lines and joints to be pressure tested and cargo doors to be operated. The hand pump is usually a double-acting pump, delivering oil on both strokes in a very compact body. It incorporates non-return valves and a relief valve, which can be set to relieve at any required pressure. Typically, this is about 10% above normal system pressure. The piston assembly is connected to the operating handle by the piston rod. In the centre of the piston, there is a transfer valve, which is spring-loaded to the closed position. When the handle is moved up, the piston assembly will move down. This will increase the pressure in the cylinder below the piston and hold NRV1 closed. At the same time, this pressure will be felt on the bottom of the ball in the transfer valve, and it will open, allowing fluid to flow from below to above the piston. As the piston moves down, the volume of fluid displaced from below the piston is greater than the volume available in the cylinder above, because of the presence of the piston rod. This excess fluid will open NRV2 and flow through the outlet. The relief valve will remain closed, as it is set at a higher pressure than NRV2. Once the piston reaches the bottom of its travel, the handle will now be moved in the opposite direction, moving the piston assembly up again. As the piston moves up, the pressure above it will increase. The spring will close the transfer valve, and fluid from above the piston will flow through the outlet. There will be suction felt below the piston, and this will open NRV1, and fluid will flow in from the reservoir. There are two types of powered pump in common use. They are the constant delivery fixed volume type and the constant pressure variable volume type. We will look first at the constant delivery fixed volume pump. A typical example of this type of pump is the spur gear displacement pump, shown here. One of the gears is driven by the power source, normally the engine, and this gear in turn drives the other gear. As the two gears rotate, fluid is carried around in the spaces between the teeth from the inlet to the outlet side of the pump. This type of pump gives a relatively large flow rate. However, its output pressure is relatively low. It is usually a single, as shown, or double-stage pump. This type of pump supplies fluid at a constant rate, irrespective of demand, and therefore if it is being mechanically driven by the engine in a closed system, it needs an automatic cutout, ACOV, or relief valve, to return the fluid to the reservoir when the actuators have reached the end of their travel and the system is not operating. Operation of the ACOV will be explained later. In order to prevent the ACOV constantly cutting in and out, this type of system also requires an accumulator. Again, the operation of the accumulator will be explained in a later lesson. The constant pressure, variable volume type of pump supplies a variable volume of fluid and controls its own pressure. This type of pump is typically fitted in modern aircraft, whose systems operate at between 3,000 and 4,000 psi. The pump is made up of a number of components. There is a stationary kidney plate, so named because of the two kidney-shaped slots cut in it. The fluid supply from the reservoir enters the pump through one slot, and the pressurized fluid exits by the other. The cylinder block is rotated by whichever source is driving the pump. Cut into this block are a number of cylinders. There is direct metal-to-metal contact between the rotating cylinder block and the stationary kidney plate. This contact is lubricated by hydraulic fluid at system pressure. Each cylinder has a piston fitted into it. The pistons are connected by shoes to the non-rotating yoke or swash plate. Again, lubrication is by hydraulic fluid at system pressure. The angle of the swash plate, and thus the piston stroke, is varied by the position of the control piston. The control piston has pump outlet pressure on one side of it and a spring on the other. With the pump stationary, there will be no hydraulic pressure, so the spring will push the control piston fully to the right, and the swash plate angle will be maximum. The entire assembly is enclosed in a case which is filled with hydraulic fluid, cooling the pump, before it is returned to the reservoir by an independent pipeline. This oil is known as case drain fluid. The condition of the case drain filters are good indicators of the condition of the pump. As the pump starts to rotate, the pistons will ride up and down the angled swash plate, moving in and out of the cylinder block. They are moving out as they pass the inlet kidney-shaped slot, so they suck fluid in. As they move down the other side of the swash plate, they are now being pushed into the cylinder block, forcing fluid out through the pressure slot. As pressure builds up, the control piston will move to the left, reducing the swash plate angle, and therefore the pump output. When normal operating pressure is reached, if no surfaces are being operated, the swash plate will be almost vertical, the piston movement will be almost zero, and there will be only a small flow of fluid through the pump. This flow is for pump cooling and lubrication. It returns to the reservoir through the case drain return line. If a service is operated, the system pressure will fall, the spring will push the control piston to the right, increasing the swash plate angle and thus the piston stroke. Pump output will increase to maintain the pressure. When the service reaches its required position, output pressure will again rise, and the swash plate will return to its no-load position. On some pumps, a solenoid-operated depressurizing valve, offload valve, can be used to block delivery to the system and to offload the pump. System pressure is maintained and the pump output falls to below 1000 psi, allowing case drain oil to circulate, lubricating and cooling the pump. This valve is useful in the event of a leak in that part of the system supplied solely by its pump. The solenoid is energized to offload the pump, so in the event of solenoid failure, the pump will continue to operate. The case drain fluid can become very hot, so it, and in some cases the system return fluid, is often passed through a cooler before being returned to the reservoir. The cooler usually consists of a heat exchanger matrix in the fuel tank, thus helping to warm the cold fuel as well as cooling the hydraulic fluid. Engine-driven hydraulic pumps cannot normally be disconnected from the engine. So in the event of an engine fire or an internal pump leak, it is necessary to have a method of isolating the pump from the flammable hydraulic fluid supply. This is achieved using a motorized firewall shutoff valve. The valve is open during all normal operations and only closed when it is called for in an emergency checklist. If the pump continues to rotate with this valve closed, it will rapidly suffer damage because of the lack of any cooling or lubricating fluid. To summarize, there are 3 types of pump in use: the simple hand pump and the 2 power-operated pump types. These are the constant delivery fixed volume type and the constant pressure variable volume type. These 2 pumps can be driven from a number of different sources, including the engine, an electric motor, an air motor, or a hydraulically operated motor from another system. Some aircraft have a ram air turbine driven pump available for emergency operation. Remember that systems using a constant delivery fixed volume pump must also have both an automatic cutout valve and an accumulator in the system.